use the, there we go. I try not to use values that I solve for it, because if I got that wrong, then I'll get the next one wrong, right? But anyways, so that's where so you're okay, you understand your error there? So for C, for C is $4.80. And then in D, I want the amount of heat. And that is for 1 hour. So 17.094 squared, 6.8445, 3,600, all over 4.19. And that works out to $1,718.38 kilocalories. 374 actually is what I had here. And I converted that into kilocalories because it was something like 37.4. So if you did it in calories, which is fine. Okay. So I answered Dalen's question. Any other questions about that guy? All right. Question 2. A lamp operates continuously across 120 volts. Power 200 watts. I need the electron flow. So in order to get that, I got to get my current first. So 200 divided by 120. .6 repeat. That's coulombs per second, which is what amps is, right? And we want it over 2 days, so that's 4,800 hours. So I've got 3,600. Oh, that's in an hour. Sorry. And then it is 6.25. Per coulomb. So coulombs cancel, hours cancel, seconds cancel. Left with electrons, and the answer is that. Okay, we've done that question 2 or 3 times now. Find your current first, which is amps or coulombs per second, multiplied by the amount of time, and that's what we get there. Okay. Number 3. Wire has 6 amps. $120 volts. That means resistance is 20 ohms. It's placed into a 1 liter or 1 kilogram So my mass is 1,000 grams of water. The time is 450 seconds. How hot will the water get? So I need the temperature. So I have so the Q for the wiring is I squared RT over J. The Q for the water is the specific heat, so MC delta T. So I let the two equal each other. All right, arrange it to get T by itself. So I've got I squared RT over J times M times C. So my I is 6, R is 20, times 450 over 4.19 times 1 times times 1,000. And that worked out to 77.327 degrees Celsius. Okay. Simple load resistance set up. VRP. Two dry cells connected in series provide an EMF of 3.1 volts each. So that's a total voltage of 6.2 volts. When a load of 5.8 ohms is connected across a battery, an ammeter in the external circuit read 0.5 amps. Find the internal resistance of each cell. Okay, so I didn't even need P for this one because there's no power involved yet. So I have 0.5 amps. That means this is also 0.5 amps. So I've got 6.2 divided by 0.5. Is 12.4 ohms. When I subtract 5.8, that gives me, I think I made a mistake here, but nope, 6.6 ohms. So therefore, each battery has 3.3 ohms of resistance in it. Okay, so the first thing I did was find my total resistance. I subtracted my load resistance to get my internal resistance, and then I divided by 2 because there's 2 batteries there. So each cell contains 3.3 ohms of resistance. All right. Number 5. Here's the long one. Electric hot plate draws 10 amps. On 100 volts. Again, the first thing I would do is get my resistance. In 12 minutes. So I've got, there's my Q all together there. Q equals I squared T over J. So without doing anything, let's find out what the heat output is for this. So I've got 10 squared times 10 times 720. So the Q output worked out to 171,000. That. Okay. Now let's work with the inputs. I have a mass of 640. Water. Change in temperature was 85 degrees. It's evaporating 140 grams. So therefore, the evaporation is 538.7 calories per gram to change it from a liquid to a gas. So my input then $640 times 85 plus 140 times 538.7. That worked out to 129,818. We divide that into the output that was being provided, and our solution 75.549%. Efficiency. All right. All right, let's look at 6. Electric iron has a mass 900 grams. We've got a heating element with a length of wire 6 meters. Looking at platinum wire. And it's 24 gauge, so the cross-sectional area was 0.002047 centimeters squared. Temperature, 170 degrees Celsius. Voltage, 120 volts. Okay, so it says what time is required this time. So I'm using the same thing I did before. Okay, so I've got output, input, both of them are heat, they're both Qs. I let them equal each other. I solve for my little t here to get it, MC delta T times J over I squared R. So the first thing I need to find is R, and then I need to find I in order to do this. So I get my R based on my resistivity information. So this right here gives me my R. I take my rho times my L divided by my A, and I end up with my R. I got an R of 2.931 ohms. I divide 120 divided by 2.931 ohms, and I get 40.94 amps. So the resistance comes from up here. The current comes from V and R. Now, normally I would say you can't use information that you solve for, but we're going to use it today because we don't have any other information to get to it. So now I fill in my equation here, 900. Iron, we didn't put that in here. Its C value was 0.1075. Temperature is 170. J is 4.19. I divide that by 40.94 squared.
Hi. Hi, Uncle Jared.
Hello, Kellyanne. Are you having fun?
Yep.
You
How are you doing?
I'm all right. Did you get to drive the quad today?
Yep.
All right, girl. What do you make?
Well, bye.
Bye. Have fun. Okay, so I get 14.028 seconds. Okay? Number 7. I'm given a diameter of 1.55 millimeters. So I change that to a radius of 0.0755 centimeters. Okay, so I divide it by 10 to get it to centimeters, and then I divide it by 2 to get the radius. Now I times it by pi and square it, and I ended up with 0.1887 squared. That's my cross-sectional area. I've got a resistance, 42 ohms. I'm looking for L, and I have a resistivity in this case of, because it is aluminum, that. All right. So when I calculated this worked out to a real large number, 280,632.44 centimeters. So you could divide it by 1,000, you could divide it by 100, whatever you wanted to change it to. But you want to change it to meters. If you change it to meters, you divide by 100. So you get 2,806.3244 meters. Okay. All right. So again, just going through if you have any questions.
Yeah, I don't know.
Yeah. You have a question about it or? You okay? Okay. Last one then. 8. Okay. 14.8 volts. 5.2 ohms. 0.3 ohms. All right, so let's just fill it in and then we'll talk about the information. So first things first, this is 5.5 ohms. 14.8 divided by 5.5 gives me 2.691 amps. So I square the amps and multiply it by the radius. So on the first one here, I get 2.172 watts. This one I get 37.653 watts. Okay, so in A, the answer is 37.653. In B, the answer is 2.172. Okay. In C, it asks, what do I change the load resistance to? I change it to the same as whatever the internal resistance was. So I could, in theory, do this all again. Hold on. Okay, so now I have 0.3 ohms, 0.3 ohms, a total of 0.6 ohms. Still have 14.8 volts. Now I need to calculate what my amps are. Square that value, times it by 0.3, and 182.53 watts for both of them. So the answer for D and E is the same thing because you've changed them so they have the same amount of resistance. Okay. Questions, comments about the assignment? We're okay, girls?
Yeah. Are you gonna go through that one for pre-calc with that Deputy's test one? Not
What?
in Deputy's test, but like the chapter 6 test. Pre-calc. I did an assignment and a test. Or 2 assignments, I guess.
Okay, which one did you want? I thought I went through one of them already.
Yeah. You did do one, but you did chapter 7 and the first chapter 6 one. But like there's another chapter 6 one that we did.
Okay, we're running out of time here today, so why don't we do that one tomorrow?
Okay.
So I'll do that for class tomorrow. So just remind me when we start tomorrow to do that, okay? I would like you to, I'm going to give you a little reading assignment today. I want you to, in your book, just read. You can either read, or if you don't want to read, do the group A questions on page 476 in physics. And that'll help you to summarize everything that's in there rather than explaining it all at one time. Okay? So on magnetism, so what I want you to do today is to read page 476. Start on page, or do the questions on page 476. That way you don't have to read it all.
Wait, what page do we, if we want to read, what page do we read again?
It starts on page 465. Okay? So that's all the theory, that'll be all the theory that we have for that next section on magnetism. So if you read through that, then tomorrow we'll go through the questions on 476. I don't expect you to have it done until Friday. So that's what we're going to do, is we're going to go through the first part of electromagnetism and get to the end of 476 by the end of class on Friday. All right, so on Friday, I'll go through the 16 questions with you on magnetism. I'll show you, maybe I'll send you a link to a video that we can watch as well on magnetism that will summarize everything that's there. All right. So for tomorrow, finish your review in pre-calculus. Tomorrow I'll go through the one assignment with you. And Friday, I will give you an assignment on chapter 8. We'll start chapter 9 Friday, but I'll give you an assignment on chapter 8 for the weekend. And for physics, we'll eventually do page 476. We'll get to the end of those questions for Friday. Okay?
Okay.
All right, you have anything else to add? Questions?